Hi, so today we're going to start with a dead board. I have no faith and no confidence that this will actually work, but it's something I want to show you anyway. So the thing is, a lot of the reason this is not a live channel is because I didn't really feel like posting the ones where I couldn't figure it out because I just figured it would be a waste of time. And in doing that, there's been a lot that I haven't filmed that I actually really should have been filming because I'm not here to show you that I know how to fix everything. I'm here to teach you the thought process behind it so that you can learn how to fix things yourself. And even if a board is deemed something that is just not worth me trying on, because in this case it was pissed on by a cat, I just move it around. This is, by the way, after an intensive ultrasonic cleaning. This is what we have left after ultrasonic. Just a mess. Oh yeah. But the point is, I want to just, I want you to learn from the process. So I don't even care if I figure out that it's not worth fixing. So let's open up the board view for this one and get started. Now, one of the things with this business that you have to realize getting into it, it's not always about whether you can figure out the problem. It's about whether it's worth it to figure out the problem. Because there are a lot of times where it will not be worth it to figure out the problem. If it takes me 5 hours to fix something that is a Core 2 Duo, and I could have spent that 5 hours fixing another 7 boards that are i5s and i7s for new machines, I just wasted a lot of my time now, didn't I? So let's open this up. So I'm going to go through this with you step by step. So the first thing, obviously, first things first after cleaning it, is the visual inspection. So you want to see where the problem is based on a visual inspection. Because you don't want to go measuring everything on the board first. So because it's just kind of a waste of time. So you want to get as many hints as you can, and you do that by actually using your brain and looking. So when I plug this in, let's see what voltages I get in the main areas. So PP bus G3 hot, which is supposed to be, let's see, 12 volts, is dead, 0. Let's see, no green light. So let's see if PP3V42 is here. Okay, I got that. On the other side of the inductor, I got 3.5. So PP3V42 is there. So let's go over to U7000, because that is what is going to be controlling, creating 12 volts. And it's not a short because I'd at least see something there that's moving up and down. I see nothing, and when I see nothing, that leads me to believe that, the chip is not working or something is blown. And I'm pretty sure I know what is blown. I'm fairly certain that what I have blown is this thing. Also, this is the thing that you almost never have to replace, by the way, so I'm almost kind of hesitant to do this as a video. So see this? I'm hoping that you can see this. I don't know where the viewable field of this microscope is until I get an HDMI splitter and another camera so I can tell. Hint, hint. Christmas is coming up. So yeah, but the whole thing with this camera over here, the camera that I have above the microscope, it sees a much smaller viewable range than what I see in here. And I'm not about to experiment and screw around and buy like 30 different cameras. I'm pretty satisfied with the, $1,000 I spent on this whole setup already. But the problem is I can't always see exactly what you see, so I'm just moving around. But see this? This is almost never the problem. Even if it's a little bit corroded, this is allowed to be a little bit corroded because it has redundant pads, so there are several pads for the same thing. But this in here just looks so completely beat to shit. And I have 0 volts on PP bus G3 hot, so on rare occasion that may actually be the problem. So let's see. So this here is Q7085. So if you look on the schematic here, not the schematic, the board view, I'm being an idiot. You'll see, hey, come on, hey, stop. So yeah, that is this thing. That's this. And on the bottom over here, it says that's Q7085. I'm sure people are going to ask me where I get these schematics, and I will, as usual, troll you and ignore you, because if you can't use Google, then you probably can't fix a motherboard. But that's for another day. So let's look on the schematic. So we got Q7085. So Q7085, what does this do? Here we go. And what do you know? This is right by U7000, which is what creates my PP bus G3 hot, which is missing. So back to this. Motherfucker. All right, so let's look at some of the basics here. So this is from the adapter. So that's the voltage that comes from the adapter up there. I need a bigger pointing stick here. Let me get a pointing stick. See, what do I have that I could use as a pointing stick? Here we go. I got a mop. All right, we'll use the mop. Mop is a pointing stick. All right. So, her and I just gonna be a rich professor someday. So, seriously, the camera's focusing on the mop instead of the screen. All right. So this is the power from the adapter. It's coming through this transistor. Then it goes to this transistor. Then it goes to this current limiting circuit here. Not current limiting, current sensing circuit here. Then it goes to this top transistor, which opens to create the pulses that you get going to this inductor. The pulses that go to this inductor get turned from the 16 or 18 volts from the charger. This inductor is going to smooth it. Instead of it being pulses, you're going to see just a flat line, which is going to become 12 volts, which is PP bus G3 hot. So up here you have the charger coming through. Up here you got charger coming through. And this is the point, one of the points which the charger comes through. But it can't come through because Q7085 is sodomized and destroyed. So let's take a look at which pads are actually destroyed here, shall we? So we go over to the board view. And let's see. So the pads of this that are actually just completely burned off to the no saving them are pins 3 and 2. Now the thing here is pin 1 doesn't seem burned off. Let's take a look. I actually can't tell. I don't know if you can see that. I can't tell if that's burned off because it's been pissed on so hard that what the hell, you know, what are you going to do? So let's take a look here. Let's try applying some solder. And see if it cleans some of the cat piss. Oh boy. Okay, so this whole thing is just... I should also turn this on. I don't want smoke going in my face. Ugh. How about we just remove that altogether? Even though I doubt it's actually bad, it's just going to make looking for pads that are missing just a little bit easier. Alright. So, zoom out here. Here, just in case I miss it in the microscope camera, let's see if I can get some in this. That's the other thing I hate about this microscope. I should have got the more expensive one. The thing is, I didn't know because on Amscope's site, they tell you what the working distance in the microscopes are. On Omano's website, they don't. So on Amscopes, it tells you have 7 inches, you have 4 inches, you have 9 inches. This, if I had known that like this is the amount of working space I had, I wouldn't have bought this shit. But live and learn. I'm not buying another microscope. I've bought 2 already, and that is 2 more than I need for most things. So, yeah, this is not exactly ideal, but it is what it is. So, you should be able to see that. So, yeah, this isn't rocket science for those of you that say, you know, I'm missing a lot of the fun by not seeing the soldering. This is basic bullshit. I heat it. It takes forever to heat because I just turned the iron on. It also takes forever to heat because that's a big ground plane, and I lift it up. Let's see what this looks like under the microscope here. Yeah, that is oh. Alright, so oh. Is there any pad hiding under there? Anything at all? Okay, at the end we got a pad hiding. There we have some remnants of a pad hiding. But yeah, I'm going to be running wires to this. I'm not trusting those pads and these disgusting traces. See what I'm doing is I'm trying to scratch and etch portions of the board off so that I can then put this here. So there's carbon, there's copper traces in there. I don't know if it's exactly copper, but you can actually etch away at the board and then solder on top of the etching, and then you've made yourself a kind of ghetto solder pad. So let's just clean that a little bit. Let's see what we have, what I can do. Let's clean off some of the junk. Of course, my alcohol dispenser decides to run out as soon as I want to make a video. Go figure. I should refill this thing. It's going to drive me nuts. I love these alcohol dispensers that you can buy from Allspec. I just love the fact that they don't work unless they're filled almost halfway up. It's like, well, the alcohol at the bottom is probably 3 years old by now. Okay. Alright, so the top three here. Let's see, what does it say over here? So the top three are going to be the source of the transistor. Let's just go over what a transistor actually does, just in case you don't know. Where's my mop? Here we go. Alright, so a transistor is actually a transforming resistor. It's a resistor whose resistance changes based on an input signal. This is something that confuses a lot of people. So see, where it says S, and then where it says D, so source to drain, that is the resistor. This resistor can be 0 ohms, 10 ohms, 20 ohms, 1,000 ohms, 10,000 ohms. What the resistance of this is dependent on the gate. So this here is the gate, which tells this whether or not to open and stop being a resistor and let the power through, or to close and not let anything through. So pins 1, 2, and 3 are the actual source coming from the charger. Then there is the drain, which is where it comes out, and then there's the gate, which tells it when to open. So this chip, the U7000, the ISL6259, sends this signal that tells this transistor when to open. So let's see. So the pin that is kind of destroyed here Alright, so this is the only pin that's not destroyed, which is the gate pin. The pins that are destroyed are the incoming pins, where we're probably going to be running a wire. Also, this is the main charger voltage. So this is going to be a higher voltage and amperage than just about anything else going through the board, so I'm probably going to be using a thicker wire for it. It's just, you know, common sense. So let's get started with that. Now, first things first, luckily I actually have the freedom of being able to use another one. So this is one of the many, many, many computers that's been left sitting here for several years, and I'm going to steal the transistor from this. I shouldn't really use the word steal, since the law says that after 49 days it's mine, and yeah, it's been like 900, 1,000 days by now, and so this is mine. Now, yes, you are going to miss the action. My table is a little cluttered, so in removing it, I am using my lap as a bench. Yeah. Oh, yeah. And I'm using my index finger and my thumb to actually to touch the tweezers, and I'm using my ring finger on the same hand to keep the LVDS away, just in case I actually do get around to properly refurbishing this computer. So now what I'm going to do is I'm going to take that old FET, and I'm going to do something that's very important, which is flick it off the table, because I'm going to forget which one of these is the new one. That's a common thing, and I'm going to drive myself nuts. So yeah, I just took that old FET and I flicked it off the table and threw it exactly where it belongs. It was on the floor with the rest of the crap that I will sweep up later today. We strive for the highest standards of professionalism here. Alright, now let's just add some solder on the pads that actually still exist. So we got this, and I am going to check that trace. I'm going to make sure that that goes where it's supposed to, and here, even though I know that that's destroyed. So, and again, the reason I said I wasn't really I'm not really excited about doing this video is because I'm going to encourage people to replace this shit when I know damn well that this is almost never the problem. So it's going to... But, yeah, please realize that this really, truly, 99% of the time is not the problem. Even when it looks corroded, it's almost never the problem. Like, again, you have 3 large traces. Even if the trace is a little corroded, it's fine because you have all the others there. This is one of those very few times where there's no traces there at all. Like, look at how much heat it takes just to solder it on. I mean, and crooked at that, which is kind of embarrassing. But let's get this lump of shit off over there. Okay, and ah, that didn't work. So now we're gonna have to get some solder on these pins. I'm actually moving this back and forth just so that you can see it because I know that there's a chance that I'm doing this outside of the microscope. I don't usually solder like a lunatic, where I'm like moving the board back and forth as I go. But I really do want you to see what it is I'm doing. Alright, so first things first, let's run a wire to the next point that comes on the board. One of the cool things about this software, even though the software is garbage that was designed in 1995 and never updated, is you can hit the N button on your keyboard and you can find every point that something shows up. So I'm going to click here and hit N, and this is called ppdcin underscore g3h underscore or underscore pbus. And look at this, it tells me all the points that it shows up. So it actually takes me to the other side of the board, where I'll be running a wire very soon. So it takes me over here. It tells me that, oh, look, on this transistor I can grab it, or on this probe point. I'd rather grab it from the nice big pads of the transistor over here, this 1, 2, 3, because, you know, it's as I said, it's a large voltage, and I'd rather grab it from a nice sturdy point. Alright, so let's turn the board over and look over here, and let's just put a little solder on that, and then I'm going to run a wire. And at the moment, since this is just for testing purposes, I'm not going to make the wire look beautiful and nice and sexy, because I don't care. I want to see if my theory works. The whole key when doing the troubleshooting is to waste the minimal amount of time as humanly possible, right? So I don't really want to waste a ton of time figuring out, you know, making something look perfect if that's not how it's actually going to wind up being, you know? You know, you could spend an extra minute making something look nice, and if that doesn't fix your problem, you just wasted a minute that you could have spent using your brain. So I have limited time every day in which I get to use my brain, and I like to use that limited amount of time to do things that are actually going to work. I can... Oh, STFU. I want to play with a new toy, but this is not the appropriate time to. I got some of these new spatula tips, but it clearly doesn't fit for this application. See how about this thing? This is a humbler right here. I don't know why I'm using a fine soldering tip for these huge pads. Okay, heat up, heat up, heat up. The great thing about inductive soldering is, look at how fast that thing heats up. So we've got some nice new solder on there. When they do the wave soldering to put this together, they use this, the way they do it, it puts the minimal amount of solder on the board, which is excellent for mass manufacturing. Excellent. But when you want to run large trace wires, is completely not ideal. I want something that I can solder to. Alrighty. Now let's get a wire and run it and see what I get. This is exactly what I think of A1150 MacBook Pros. They are useful for this little wire. But fixing that thing, psst. No, I'm not fixing your machines here. 120 gigabyte Fujitsu drive can die tomorrow, and your X1600 graphics card can die tomorrow, and your CCFL backlight can go out tomorrow, and you can blame me for all of this because I replaced the key on your keyboard. I learned my lesson on that one. Fool me once, shame on you. Fool me 250 times, shame on me. Okay, so we tin the wire. By tinning the wire, I really should put this down so you see more of the action. Yeah, you don't really need to see my face anyway. So when I tin the wire, the whole idea here is to put some solder on the end of it. And cut it, make it a little smaller. Let's see. How long should this thing be? So from about here to about... This is fine. Okay. Alrighty. Puh. Ugh, solder. Fuck off. Go in there. Very good. Okay, now... See where it is? See what I'm doing? Again, I don't know where the microscope camera focuses, which is why I'm moving it around like this. Alrighty. Alright, let's see if our work has done anything, or if it just sets the machine on fire. No fire. Okay. No fire is actually a step in the right direction. Now at least we have 16 volts at the top where we're supposed to, but I have nothing at PP bus G3 hot. Second thing I want to focus on is getting a green light. So before we even do that, see what's going up here. What's going on up here? Oh. Alright, so I've talked to you about the one-wire circuit before, right? So U7000 shoots out this signal called charger HAKKO. I know, laugh, it sounds funny. Trust me, I do sometimes as well. See where it says charger HAKKO out? This goes to... this is also assuming that you have charger AC in. So once charger AC in here is 4 volts, there's a voltage divider over here. This voltage divider goes from the charger to here. It takes the 16 or 18 volts of the charger and turns it to 4 volts. So if it sees AC in here, it shoots out charger HAKKO here. Now once it shoots out charger HAKKO there, it goes to... Come on, load my PDF, mofo. Act like a 6-core i7 and not like a 2-core duo. Here we go. Oh, whatever. Okay, I'm just going to cheat because I knew where it is, even though my PDF reader is being a piece of shit. So that goes over here and becomes SMC BC HAKKO right over here. Now, this is a logic gate, and it passes this SMC BC HAKKO signal onto here. And if this SMC BC HAKKO signal is present here, hey, where'd you go? Get back here, get back here. Okay, so if SMC BC HAKKO is present here, and adapter sense is present from the charger, sys1 wire goes out. And if sys1 wire goes out, it knows to turn on the green light. Now, one of the common issues, since this is a very small trace right on the edge of the board where liquid goes to, is that PP3V42, which powers this logic gate, goes away. So let me show you where that is. So U6901 on the board is this thing. See how sad this shit looks? And see this? I know I'm not getting 3.42 volts here. Now this over here also gets 3.42 volts, but again, it's covered in this remnants of, cat piss. So you can run a one wire from here to here, and most of the time fix the circuit. Wow, that pad doesn't have 3.42 volts either. Alright, let's just grab it straight from the source, which is from that inductor that I showed you. This is the wrong way to do it. But then again, this is a piss damage board I don't expect to work again. So I'm doing it the way it is convenient for me right now. Alright. Shoo, go away, you're broken. Okay, so check it out. So what I did is I grabbed 3 volts from the inductor that creates PP3V42 in a very, very ghetto and poorly soldered fashion. So let's just get that on the screen here. I think it's L6995. So here we go. So this is the PP3V42 power supply. I have a pointing stick. Over here is where PP3V42 gets created, right? See that? PP3V42 G3 hot reg. So what I did is I went to that IC where there was no ACOG coming out. So here's SMC BC ACOG coming in. It's supposed to shoot it out to send out to here. And when this chip over here sees the adapter, the pin of the adapter that says adapter sends, when adapter sends and SMC BC ACOG come here at the same time, it shoots out sys1 wire, which allows you to get a green light. So as you can see now, I have, or barely can see, a green light. I'm not going to zoom in on that because, let's see if I can. See that, mofos? Green light. Alright. And the other thing that's pretty cool that I have now that I didn't have before is I have PP Bush 3 hot. So let's go over to here. So remember the transistor that wasn't opening? So I had this transistor over here. See this? Q7085 that wasn't opening. Nothing was coming through here. Now, what I have is it is opening, which is allowing power to come through to this resistor, which is allowing power to come through to this buck converter here. A buck converter is something that takes a higher voltage and turns it into a lower voltage through switching. So this is going to switch on and off and send 16-volt pulses to L7030. Let me look at L7030 just so I can show you how this works. So when I say buck converter and pulses and smoothing and all this, I'm probably confusing the fuck out of you. Let me just show you on the oscilloscope to make this very, very easy. I like using the oscilloscope as a learning tool. So once all that voltage comes through, let me show you what the buck converter is actually doing. And hopefully in turning this board upside down, I don't destroy it, because it literally has been pissed on. And let's zoom in on my oscilloscope. Focus, fucker. Yeah, let's see. Let's see if we got some manual focus here. Can I get manual focus? Manual focus. Here we go. Okay, let's see if I can make this look better. Probably not, but worth trying. Whoa. Alright, so here is before the buck converter. So there were those 2 transistors. Those 2 transistors go to an inductor. So before the inductor, you get this. You see all those spikes? That's the actual charger voltage, but it's being switched on and off, on and off, on and off, on and off. That transistor is turning on and turning off at a very high frequency, and you can actually measure it. See over here, it says frequency is, let's see if focusing does anything. You probably still can't read that. I'm trying to focus on the LCD on the camcorder, which is just god-awful shit. Let's just go back to autofocus. Anyway. Alright. So this is before. The switching is actually occurring at a frequency of 403 kilohertz, according to this. And that is the charger voltage. So each one of these vertical lines is 10 volts. So you have 10 volts, because it says 10 volts over there. That's what it's set to. So you should use the stick so you can see. So here, it's set to 10 volts per one line. So you have this one line over here is 10. So you can tell that that's about 18 volts from the charger up there. And you see 18 volts, then 0. Then 18 volts, then 0. Then 18 volts, then 0. And what happens is the inductor can only pass DC. It can't pass AC. This here is actually, believe it or not, some kind of looking AC. So look, it's going up, down, up, down, up, down, up, down. The inductor it can't do that. The inductor can't do up, down, up, down, up, down. The inductor can only do straight. So this is before the inductor. After the inductor, you have something that looks like this. It's straight, but it's a lower voltage. So instead of it being the 18 volts of the charger, what you have here is the 13 volts that is what the machine actually runs on. This machine actually runs on 12.6, not 13. It's probably making 13 because it's been pissed on. But before, when I first measured this in the beginning of the video, it had 0 and it had no green light. So we've made some progress here. So this board works more now than it did before. So the first thing that I did is I fixed the issue in the charger circuit where the power for the charger was not able to reach the buck converter because that transistor was physically destroyed, and so were the pathways on the board. I shouldn't say the transistor was destroyed because I didn't test it, but the pathways on the board were not actually there. And what I did to fix that is I ran that wet wire. Now, even after I did that, this still was not working. It wasn't working because the one-wire circuit was not working. So if the one-wire circuit is not working, the SMC is not going to tell the U7000 on some boards that it can work. On some boards, it will. On some boards, it won't. I honestly don't know the science behind that, but what I do know is that I still had 0 volts over here, and then when I fixed the one-wire circuit, I got my 13. So let's see what else works on this piece of crap, if anything, because again, it's been pissed on. Like I have truly no faith or confidence in this shit ever turning on properly. But it's fun. I actually just plugged RAM into it while the charger was plugged in, so I'm probably, adding to destroying it. I am usually more careful when I'm working on stuff for actual customers. This is something that's been abandoned for me, so I'm treating it like I treat my own things. I treat my customers' items like gold, but I treat my own things like, yeah, I don't know. Alright, so let's see if this thing actually turns on when you short these two pads. No chance in hell. Which is exactly what I was expecting. Actually, I don't know if the fan is good. Yeah, there are other things that we can check for, voltages that should be showing up that are not. PP5VS5. So on PP5VS5, I'm supposed to have PP5VS5 and PP5VS3. That's 5 volts in hibernate stage or turned off, and 5 volts in suspend stage. I get, let's see. Zero. Well, unfortunately, this board doesn't turn on because it's fucked. The video actually froze for a moment. It froze where I was measuring for RTC, and this board actually does have a bad MCP, since it has been pissed on by a cat, and since this is 5 years old, and since I don't want to buy chips that don't exist new for something that is 5 years old so that I can resell it for a low amount of money, assuming that I'm able to fix all the other cat piss problems. This board goes in the bin. But hopefully you learned something. Hopefully you learned a little bit about the troubleshooting process, even if it was with something that has no ability to work again. Again, it is good to learn, and I'm going to try to do more of these. Even if I don't actually fix the problem that I sought out to fix, there's really no reason to not upload the video so that you can at least learn something from the problems that I did fix along the way. And I have, again, I have learned at this point when to just stop, when to give up, and that is one of those times. I'm not buying a chip for a 5 or 6 year old board when it's been pissed on by a cat. I've made good progress. I could continue down a rabbit hole with this, fixing each individual problem one by one, but I will be here until 4 in the morning. And here's the thing, and this is something that I've told a lot of people about this business. So let's say you're slow at what you do, right? Let's say you're not really fast and efficient. Here's the thing. And here's the thing with failing in this business, and it's something that I try to bang into the head of all the people who work here. If you fail at something, and God, this thing's noisy. If you fail at something, but it took you an hour, or maybe even an hour and a half, it sucks, but it's not that bad. If you fail at something and you took 5 or 6 or 8 or 9 hours on it, that's bad. Again, I fail over and over again over the course of a day. I may fail 10, 20, 30, 40 times over the course of a day, and the reason that that is acceptable is because I fail in very, very short increments. And here I want to do a video, and I'm moving slow while I'm doing a video because I want to explain everything as I go. But usually I would have spent maybe no more than 2 minutes on that board before I tossed it in the bin after I got this far with it. But I don't want to spend a lot of time on something if there's a chance of failure. The only time I'm going to do that is if there's a really, really big reward. And the reward that I get from fixing a motherboard that has a resale value of maybe $250 that's just not doing it for me. So again, hopefully you learned something from this. That's about it.